This video guides you how to create keys and certificates for use with the FreeRTOS PubSub demo with trusted secure IP. Download the root CA certificate from the URL on the screen. Copy the downloaded certificate to the following folder. Copy the client certificate public key, and client certificate private key downloaded from AWS IoT to the following folder. Next, we will create a signature for the root CA certificate. Run cygwin and type a CD and a space on the screen. Next, right-click on the address bar in Explorer and select Copy Address. Finally, right-click on cygwin, select Paste and press Enter. Type the following command in cygwin and press Enter. The root CA certificate signature data signed with the private key is created under the following folder. Copy the generated root CA certificate signature data, Amazon root CA1_sig_array.txt, to the following folder. Next, we will explain the procedure for converting the client certificate private key downloaded from AWS into a secure form and storing it in the flash memory of the CK-RX65N board. By converting the client certificate private key into a form that can only be interpreted by the TSIP driver, the key information can be managed securely. The user factory programming key, UFPK, and UFPK wrapped in the Renaissance key wrapping service, and the security key management tool are used to convert the client certificate private key. Perform the conversion of the user key, the public key for the root CA certificate public key and the client certificate public key, in the same way. UFPK is the key used to encrypt the client certificate private key, and is created by the customer. In addition, WUFPK is the key that converts UFPK into a safe format that can only be interpreted by the TSIP in the RX microcontroller. For this reason, the first step is to create a user factory programming key, UFPK. Launch the security key management tool and select RX family, TSIP. Click on the Generate UFPK tab and follow the on-screen instructions. Then click the Generate UFPK key file button to generate the UFPK file. The conversion of UFPK to WUFPK requires making requests to Renaissance Secure Site. In order to prevent UFPK from being leaked during communication, Renaissance PGP public key is used for encryption. Launch Cleopatra and click Sign/Encrypt. In the file selection dialog, specify sample.key. After setting up as shown on the screen, click Sign/Encrypt to generate a PGP encrypted UFPK sample.key.gpg file. If you check Protect the generated key with a passphrase, enter the passphrase value you set earlier. Next, we will encrypt the PGP encrypted UFPK with the Renaissance Key Wrap Service, WUFPK. Log into the Renaissance Key Wrap Service and click Renaissance RX. On the device selection screen, click RX65N RX651 Encryption of customer's data. Then click Encryption Service for products. Click Reference, specify the sample.key.gpg file, UFPK, PGP encryption, and then click Settle. When this screen is displayed, encryption starts on the Renaissance DLM server. When the encryption is complete, Renaissance will send you an sample.key_inc.key.pgp file, WUFPK, PGP encryption, by email, so save it in a folder of your choice. The next step is to decrypt the sample.key_inc.key.pgp, WUFPK, PGP encryption, sent by Renaissance with your open PGP key pair to create a WUFPK, encrypted UFPK. In Cleopatra, click Decrypt/Verify and select the sample.key_inc.key.pgp file, WUFPK, PGP encryption, on the file selection screen. If you check Protect the generated key with a passphrase, enter the passphrase value you set earlier. When the completion screen appears, click the Save All button to save the decrypted key. The sample.key_ing.key file, WUFPK, decrypted in the same folder as the file before decryption is output. Next, we will explain how to enter the data of the root CA certificate public key, the client certificate public key, and client certificate private key, and the sample.key, UFPK, and sample.key_ing.key, WUFPK, into the security key management tool to generate a wrapped key file. First, create a root CA certificate signature verification public key. Launch the security key management tool and configure the settings as shown on the screen. Then follow the instructions on the screen and select RSA2048 public.pem in the following folder. Configure the settings as shown on the screen in the output field, and click Generate File to generate the root CA certificate signature verification public key data. Next, generate a client certificate public key, wrapped, for the client certificate. Rename xxxxpublic.pem.key to xxxxpublic.pem in the following folder. Launch the security key management tool and configure the settings as shown on the screen. Then follow the on-screen instructions and select xxxxpublic.pem in the following folder. Configure the settings as shown on the screen in the output field and click Generate File to generate the client certificate public key data. Next, generate a client certificate private key, wrapped. Rename xxxxprivate.pem.key to xxxxprivate.pem in the following folder. Launch the security key management tool and configure the settings as shown on the screen. Then follow the instructions on the screen and select xxxxprivate.pem in the following folder. Configure the settings as shown on the screen in the output field and click Generate File to generate the client certificate private key data. Copy the 6 files created in the previous steps to the following folder. The following video shows you how to build the demo project.